Heisenberg uncertainty principle, one of the topic from quantum mechanics for the preparation of KSET or NET exam. Heisenberg uncertainty principle is one of the very important topic from quantum mechanics. If you understand wave particle nature, so that is de Broglie wavelength, if you understand that concept, you can understand Heisenberg uncertainty principle. So I have already explained in the previous video, just go to that video. First you should know the statement of Heisenberg uncertainty principle. So according to this principle, which states that it is impossible to measure or to calculate exactly both the position and momentum of an object. So you cannot predict directly position and momentum simultaneously. Either you can measure momentum or position. So both cannot be possible simultaneously. What exactly the Heisenberg principle states. So here if we want to represent mathematically, we can represent it as delta x, uncertainty in position and uncertainty in momentum, which is equal to the Planck's constant, which is greater than or equal to h cross. H cross is what? H equal to 2 pi. So then you can understand with the diagram here. If you take the electrons which revolve in particular orbit, if an observer want to identify the electron position and its momentum, it's highly impossible. So either he can predict position or momentum. So both are quite impossible. So with the help of mathematical expression, we can represent here. So delta x is what? Change in electrons position, delta p change in electrons momentum, and h Planck's constant. So similarly, there is uncertainty in energy and time. Another example is energy and time. You can't predict or you can't measure or calculate simultaneously energy and time. So uncertainty in energy delta E, uncertainty in time, the product is greater than or equal to Planck's constant. H cross is what? H divided by 2 pi. That means the value is 1.054 into 10 to the power minus 13 joule second. So H is equal to what? 6.625 into 10 to the power minus 34 joule second. So angular, another example for uncertainty is angular momentum and angular position or theta angle. You can't predict both simultaneously. Therefore, uncertainty in angular momentum and product of uncertainty in angular position is greater than or equal to h cross. So let us solve some of the problems on this today's topic. First example, assume that the uncertainty in the location of a particle is equal to its de Broglie wavelength. Calculate the uncertainty in the velocity of the particle. So in this question, they are asking to find out the velocity uncertainty. So first you should write on the uncertainty in position and momentum. Momentum, if you write, you can represent it in velocity. So delta x delta px is equal to h cross. Uncertainty in position and momentum. So then momentum is what? Product of mass into velocity. If we considering uncertainty in momentum, then that is m is equal to delta v. If you substitute here, so delta v exactly we want to calculate h cross divided by m into delta x in the denominator. So h cross divided by This we can represent it as lambda, because the uncertainty in position is nothing but the wavelength, change in the wavelength, that is lambda equal to h divided by m into v, according to what the de Broglie wavelength, as they have given in the question. uh, Uncertainty in the location of particle is equal to de Broglie wavelength, that's why we should replace with lambda. Lambda is equal to what? H by mv. So m get cancel, h and h by 2 pi if you take get cancel, and remaining what? If you take velocity to the numerator, v by 2 pi. So this is what the uncertainty in velocity. Example 2, find the average time that the atomic system remains in the energy state whose spectral line width is 10 to the power minus 4 angstrom for the wavelength 4000 angstrom. In the question here they have clearly mentioned you should find the average time. That means how the time is uncertain to the energy equation, as I explained you. Write down that equation from energy time uncertainty relation, that is delta E into delta T is equal to H cross. So delta T is equal to what? H divided by 4 pi, or sometime H cross by 2 also we write. The uncertainty in time and energy, so H divided by 2 pi into 2 4 pi. So H divided by 4 pi into delta E is equal to H divided by 4 pi, as it is you keep, and delta E is what? The energy state whose spectral line width is given by 10 to the power minus 4 angstrom for the wavelength 4000. So there is a formula for the uncertainty in energy, Hc divided by lambda square into delta E. Put this equation, calculate by putting the values of wavelength, speed of light and change in wavelength. Answer you will get the uncertainty in time is 4.24 nanosecond. So the next one, suppose that the momentum of a certain particle can be measured to an accuracy of 1000. Determine the minimum uncertainty in position of the particle if the particle is, first one, 5 into 10 to the power minus 3 kg moving with the speed of 2 meter per second, an electron moving with the speed of 1.8 into 10 to the power 8 meter per second. So according to the given question, they are asking to find the uncertainty in position. They have given the uncertainty in momentum to the p, momentum delta p by p is equal to how much? 10 to the power minus 3. So delta p is equal to what? 10 to the power minus 3 into p, minus 3 into m into v. Therefore the minimum uncertainty in position of the particle will be delta x minimum is equal to h divided by p value. You should substitute from this one, p h divided by m v into 10 to the power minus 3. Then calculate by putting the rest mass m naught into v. You will get the minimum uncertainty in position. And in the second question, the weight has been given 5 into 10 to the power minus 3, m is equal to, put the value, and velocity 2 meter per second in this equation. An electron moving with a speed of 1.8 into 10 to the power 8 meter per second. So uncertainty in minimum in question 2, h is equal to root 1 minus v square divided by c square. So here electron moving with speed what 1.8 into 10 to the power 8 meter per second. Put the value of velocity here v square, whatever the given value, and calculate. You will get the uncertainty, minimum uncertainty of 2.57 angstrom. So another example, average time interval that elapses between the excitation of an electron and the time it radiates energy is 10 to the power minus 8 second. Calculate the uncertainty in the energy of the emitted photons and the limit of accuracy with which frequency of the emitted radiation may be determined. Delta E we have to find out here. So H divided by delta T. So delta T, how much they have given? Minus 10 to the power minus 8 second. So here limit of the accuracy with which frequency of the emitted radiation may be determined. So delta V is equal to what? Change in frequency delta E by H, because E is equal to what? H nu. H into nu. So put the value of H here and delta E, you will get the change in accuracy or the frequency 10 to the power 8 cycle per second. So like this you should solve the problems related to uncertainty. So compulsory one question